Pasteur is microbiology institute dedicated to study infection disease and microbiology. We have several R&D questions and development, and among the main questions that we try to develop inside Pasteur is nosocomial infection. Nosocomial infection is really a big issue in the world, and this problem is aggravated by the fact that there is antimicrobial resistance, and among the different bacteria that have showed problem now is Acinetobacter baumannii. And the game of this work and the goal of this work is to put in place preclinical model using bioluminescent imaging in order to put in place means and model that can be deployed in order to evaluate efficacy, violence, and different drugs that can be deployed against Acinetobacter baumannii. Donc, Acinetobacter baumannii is a part of multi-drug resistant bacteria and is a part also of ESCAPE, which is a group of bacterial strains that represent higher risk for healthcare. And among this group, we have Enterococcus faecium, Staphylococcus aureus, Klebsiella pneumoniae, Acinetobacter baumannii, Pseudomonas aeruginosa, and also Enterobacter. Acinetobacter baumannii is highlighted among the main problem in healthcare, as we are facing a new emergency of carbamazepine resistant strains that we don't have any or few possibility to treat this kind of infection. That's why the WHO raised the threat level at urgent, which means there is a urgent need to put in place means and the possibility and research in order to develop activity to found the drug or other activity against this bacteria. Donc the goal of this work is to, in several parts, to put in place this model that can be deployed to evaluate this efficacy. Donc this work, as I explained, was done in collaboration with Institut Pasteur at Paris and also with CIMI. Donc we select several models. The main model that is relevant for Acinetobacter baumannii, that was well described in clinical infection, was the pneumonia and the bacteremia model. That's why we developed a mice model that can mimic what's happening in clinical way using these two kind of infection. Look, our work was done in several steps. The first one, and this is the main question that was raised during this project, is to find Acinetobacter baumannii. That's why we set up a collaboration with an intensive care unit in order to isolate clinical strain that have available and is relevant to be deployed for any preclinical model. And we succeed to have several strains that is isolated from this intensive care unit. The second step was to evaluate the violence of these strains in mice model. Now, we start firstly by transforming this strain to be bioluminescent, as we would like to use the imaging system for longitudinal monitoring of infection. Donc, we start by transforming this strain using bioluminescence plasmid. Then, when these two strains or three strains was transformed, the next step was to evaluate if the fact that this strain was transformed, we have the same violence. That's why we start by comparing the violent strain with the wild strain compared to the one was transformed. When we confirm that we have the same violence between the two strains, we start to the activity of putting in place the model. And as we explained, we select the more relevant model for clinical infection, which means the pneumonia model, and we infect mice by intranasal route. And the second model, which is relevant also, is the septicemia model. For that, we infect mice by intravenous models. And for both models, as we are dealing with bioluminescence, we can put in place longitudinal monitoring of the infection. Now here I will show you just the second step, because we have firstly evaluate the violence of this strain and select optimize the challenge that will be deployed in our mice models. Now when we select the best and the optimal challenge that can be deployed, second step, we start to evaluate and validate the model by using antibiotics and follow the kinetic of infection. So the first, I will speak about the pneumonia models when we are using immunocompromised mice. Why? Because we would like to mimic what's happening in clinical way, and generally the nosocomial infection is happening in immunocompromised persons. That's why we are dealing with immunocompromised mice with cyclophosphamide. So then we start to infect mice by for septicemia by intravenous route. Then we treat by imipenem, which is among the reference drugs that can be deployed against Acinetobacter baumannii. And in order to follow in different time points the efficacy and also the infection. We sacrifice mice at different time points and we take lung, and for each time point we evaluate the bacterial challenge in order to correlate between control and the group of treated one. So in order to evaluate what's happening, we have several readouts. The main readout that we deployed firstly is the bioluminescence, and we can see here that we can follow the kinetic of infection among untreated group, which is our control, and the one treated with imipenem, and we can see that the evolution of infection from 0 hour until 24 hours. And at each time point that is described here, we sacrifice 3 mice in order to have the CFU and evaluate the bacterial charge. And in order to evaluate the efficacy, firstly, the first readout was bioluminescence, and we can see that we have significant difference between treated and control group at 24 hours that is showed here, and we can see that there is less signal in the group of treated compared to the control one, which show that the bioluminescence can give us a means to follow the infection at different time points, but also at 24 hours. And to confirm such data, we have CFU, and that show that is in correlation with bioluminescence, and show that there is significant difference at 6 hours that we can see here. And the second one at 24 hours, we had significant difference between control group and treated one. The second model that we put it in place is pneumonia. It's also a relevant model for Acinetobacter baumannii. We use the same protocol, which means we are immunocompromised mice with cyclophosphamide. Then we infect mice in this model by intranasal route, and we treat by imipenem at different time points. And we follow the kinetic of infection using bioluminescence. And also we sacrifice mice at the end of experiment to show the efficacy of treatment by comparing the control group and the treated one, and show that there is a difference between both. Donc, the first readout is bioluminescence. It's quite similar to the readout that is done by pneumonia, which means bioluminescence can give us the possibility to follow what's happening at different time points. And we can see here the evolution of infection. Here is the control group, which means there is no treatment, and the treated one with imipenem. And I focus the image in the lung region, and we can see here at 0 hour at the time of infection that we have quite similar infection in both groups. Then we see the kinetic of infection at different time point, 2, 4, and 6 at 24 hours, and we can see clearly between two groups, and that there is a clear reduction of bioluminescence in the group treated compared to the untreated group. This data is confirmed by following the ROE, which means we select region of interest in lung, and we evaluate the volume of the quantity of photon, and we compare between two groups. And this shows that we start to have here significant difference between both groups at 6 hours, which is what also confirmed at 24 hours between two groups. It's only using bioluminescence. We confirm this data by CFU, which means we sacrifice mice at 24 hours, we compare between two groups, and we confirm statistically that there is a significant difference between control and treat group, which is in correlation of what you demonstrate also with bioluminescence. So we offer with this kind of model two nice models, two relevant models can be deployed to evaluate the efficacy and the violence, also to study the violence of different strain of Acinetobacter baumannii is the main conclusion of this project, which means we have put it in place these two relevant models with different strains, but we need to develop other questions around this Acinetobacter baumannii. Donc the first one, we need to have more strains, donc we need to collaborate more and to have more contact with intensive care unit to have new strains, and also the carbapenem resistant or other resistance that can be selected with carbapenem resistance to develop the lung models, as it will be the more relevant as pneumonia. Donc we need to put more other strains to develop and to evaluate the efficacy. The other aspect with Acinetobacter is what is now described is the multibacterial infection, which means we have several bacteria that can be interact in the same time to create this kind of infection. It can be for lung infection, but also another one model that can be also relevant for Acinetobacter and was now described in several times using Acinetobacter baumannii and isolate antibacterial resistant strains is the wound biofilm. In conclusion, we succeeded to put in place two relevant models that can be deployed to study violence or any drug efficacy against Acinetobacter baumannii. but also we are able to put in place another new relevant model, is wound biofilm infected by Acinetobacter, and we are open to any collaboration to put in place such kind of model to develop a question and study around Acinetobacter baumannii.